Assalamu alaikum. I'm engineer Hamna Shakil. In this video, I will solve problem 111, which is related to axial stresses in truss. The problem statement states that for the truss shown in figure, calculate the stresses in members CE, DE and DF. The cross-sectional area of each member is 1.8 inch square. Indicate tension or compression. So you have to find stress in these three members, CE, DE and DF. And you have to indicate whether you have tension or compression in these members. To find the stress in each member, you first need to find the force in each member divided by area. So area is 1.8 inch square and you have to find the force that is developed in each of these members. The first step is to first find the global reactions on this truss. So you'll have a reaction Ra on A and a reaction Rf on the support F. Applying equilibrium equation, that is sigma Fy equal to 0. So you have Ra in the upward positive direction plus Rf in the upward positive direction minus 30 kips, that is in downward direction, equals to 0. So it gives you Ra plus Rf equals to 30 kips. This is your equation number 1. The second equilibrium equation is sigma Fx equals to 0. There is no horizontal force acting on this system, so you cannot use this one. The third equation is sum of moments equal to 0. Let's take moment about this support F. So it will be Ra multiplied by the distance, that is 8 plus 8 plus 8, which is 24. And this Ra is causing a clockwise moment, so we are taking it as positive. Then you have this 30 kip force acting, and this will cause anti-clockwise movement, so this will be minus 30 kips multiplied by the distance, that is 8, equal to 0. When you solve this, you get Ra equals to 10 kips. Plug this value in equation number 1 here and you will get 10 plus Rf equals to 30. This gives you a value of Rf equals to 20 kips. So you have got Ra equals to 10 kips and Rf equals to 20 kips. Now we can move on to the next step, that is to find the forces developed in members CE, DE and DF. To solve the truss, you have two methods. One is method of joints and the second one is method of sections. You can use either one of these two methods to solve this truss and find the forces in the concerned members. I'm going to use method of joints. In this method, you isolate a joint, draw a free body diagram of that and use equilibrium equations to find the unknown forces. You have to find the force in CE member, DE member and DF member. So these are the three joints that we can isolate and draw free body diagram of and find the unknown forces. Let's start with joint F because it has only two unknown forces and we can use two equilibrium equations, that is sigma Fx equals to 0 and sigma Fy equals to 0 to find the unknown forces. If we select this D joint, it has three unknown forces and you have two equilibrium conditions, so we won't be able to find the unknown reactions. And if we select joint E, it has four unknown forces and you have two equilibrium conditions, so you won't be able to solve it. So let's start with drawing a free body diagram of joint F. So here you have got joint F. You have a reaction force of Rf equals to 20 kips acting on joint F, and then you have a force Df and force Ef. Right now you don't know whether these forces are compressive forces or tensile forces. So you have to make a guess. Here I can see that RF is acting upward, so there must be a force acting downward to balance this RF. So if I select the direction of this DF force towards the joint, then the Y component of this DF force will balance out this RF. The X component of this DF force will be acting in the right direction, so there must be a force towards the left to balance out this force. So I will select the direction of EF force towards the left. Don't worry too much about the direction of these forces. This is only a guess. Don't worry too much about the direction of these forces. If your guess is right, you will get a positive answer, and if your guess is wrong, you will get a negative answer. Also note that the force that is acting towards the joint is compressive, and the force acting away from the joint is tensile. So right now my guess is that the force in DF is compressive because it is towards the joint, and the force EF is tensile because this is away from the joint. Now we have free body diagram of joint F. We can further solve it. You can apply two equilibrium conditions on this joint, sigma Fx equals to 0 and sigma Fy equals to 0. For that you have to find the x and y component of this df. And to find the components of this df, you need to know this angle theta. You can find this angle theta from this figure here. This is a right angle triangle. You have 6 foot here and 8 foot here. It means that the length of this df member is 10. So sine theta will be equal to 6 by 10, which is equal to 3 by 5, and cos theta is equal to 8 by 10, which is equal to 4 by 5. So the y component of this df will be df sine of theta, which is equal to df into 3 by 5. And the x component of df will be df cos of theta, which is equal to df into 4 by 5. For sigma fx equal to 0, you have minus ef plus dfx, which is equal to 4 by 5 df equals to 0. And for sigma fy equals to 0, you have minus dfy, which is equal to 3 by 5 df plus 20 equals to 0. So this equation gives you a value of df equals to 33 whole 1 by 3 kip. Put this value of df in this equation and you will get a value of ef equals to 80 by 3 kip. Now you can see that you have got a positive value for both ef and df. It means that the direction we guessed at the start was correct. So the force in member df is compressive because it is towards the joint, and the force in member ef is tensile because that is away from the joint. Now we know the value of df. The next joint I am going to select is D. Because it has 3 members, the value of one of the members is known and there are only 2 unknowns left, and you have 2 equilibrium conditions, so you can solve joint D. So this is joint D. We have already established that the force in member DF is compressive. That means that it is towards the joint and the magnitude is 100 by 3 kips. So I am going to guess that the force in member DE is downward or away from the joint, and the force in member BD is towards the joint or compressive. So here you have got DE force and here you have got BD force. So if you apply equilibrium conditions, sum of Fx equals to 0, Here you can see that both these angles, let's call it phi, are same because these two triangles are symmetric. So this will be the x component of BD, and here you'll have x component of DF. So if you write the equation, that will be BDX minus DFX equal to 0. It means that BDX will be equal to DFX. So the x component of BD and the x component of DF are same. It means that the force BD will be equal to the force DF. And we have already found the force in DF, that is 100 by 3 kips. So that will be the force in BD. Now let's apply the other equilibrium condition of sigma Fy equal to 0. So that will become, so this is the y component of BD and this is the y component of DF. So if you write the equation, it will be BDY plus DFY minus DE equals to 0. BDY is equal to BD cos of phi and DFY is equal to DF cos of phi. You have to find the value of cos of phi. So this is your angle phi. This length will be 10 and cos of phi is equal to 6 by 10, which is equal to 3 by 5. So this equation will become 3 by 5 BD plus 3 by 5 DF minus DE equals to 0. The value of BD and DF is 100 by 3. Put it in the equation. DE will be equal to 40 kips. Again, you have got a positive answer. It means that the direction selected for DE was correct. So we guessed the direction of DE as acting away from the joint and we got the positive answer. It means that it is actually away from the joint and the forces that are away from the joint are tensile. Now let's move on to joint E. A force of 30 kips is acting at joint E. The force EF is 80 by 3 as we have already found, and that was a tensile force acting away from the joint. The force DE is equal to 40 kips acting away from the joint. It means that it is tensile. The force EB is unknown, so you have to guess the direction of EB force. I'm going to guess it away from the joint. And the force EC is also unknown, so I'm going to guess that that is also acting away from the joint. So there are only two unknown forces, EB and EC. So you can use two equilibrium conditions to find the values of EB and EC. So the two equilibrium conditions are sigma Fx equal to 0 and sigma Fy equals to 0. So you have to convert this EC force into two components, ECY and ECX. For that you need to know this angle. Let's call it alpha. So here you have got that angle alpha. This is 6, this is 8, so this will be 10. So sine of alpha will be 6 by 10, which is equal to 3 by 5. Cos of alpha is equal to 8 by 10, which is equal to 4 by 5. So EC x will become EC cos of alpha, which is equal to 4 by 5 EC, and EC y will become EC sine of alpha, which is equal to 3 by 5 of EC. So let's start with sigma Fx equal to 0. It will be equal to minus EB plus EF minus ECX equal to 0. For sigma Fy equal to 0, it will be dE, which is equal to 40 minus this 30 force minus ECY equal to 0. So this will become 10 minus 3 by 5 of EC equals to 0. So the value of EC is equal to 50 by 3 kips. Again, you have got a positive answer. It means that the direction we guessed for EC is correct. EC is acting away from the joint, and away from the joint force is tensile. So these are the forces in the members. In CE, you have force 50 by 3 kips, that is tension. In member DE, you have 40 kips, tension. In DF, you have 100 by 3 kips, which is compression. To find the stress in each section, use the formula stress is equal to force divided by area. For stress in member CE, force is 50 by 3 and the area is 1.8 inch square. So the stress in CE is 9.26 KSI. Stress in DE is equal to 40 by 1.8, which is equal to 22.22 KSI. And stress in DF is equal to 100 by 3 force divided by 1.8, which is equal to 18.52 KSI.